Akio Toyoda is trying to do with his company is try to push it to be more entrepreneurial.
Let me begin by thanking all of you for taking the time with your investment in Toyota.
Long regarded as the world's largest and most influential automobile manufacturer, Toyota is now facing a new era of challenges that threaten its reign. The rise of electric vehicles and the emergence of innovative, tech-savvy automotive companies have spurred an evolution in the industry, pushing established giants like Toyota to adapt or risk losing their market dominance. But the automaking giant is not taking it lying down. Instead, Toyota has just played its trump card. Fully confident about this new move, the Toyota CEO has proclaimed that the likes of Elon Musk and other EV manufacturers will be thoroughly shocked when they see the new Toyota motor. There's a lot to uncover, so let's get started. Toyota's position in the face of EV dominance. As the world transitions toward electric vehicles, many established automakers are recalibrating their strategies to keep up with this rapidly growing segment of the market. However, Toyota, the world's largest automobile manufacturer, has managed to maintain a steady course despite the dominance of electric vehicles in the industry. After all, it's not easy to start from scratch, and then there's an established demand for Toyota vehicles. Toyota's recent global sales figures revealed that while EVs are gaining ground, they have had minimal impact on the company's growth. Only a small fraction, less than 1% of Toyota's total sales were electric vehicles. This means that the company still relies on traditional powertrains, such as hybrid and internal combustion engine vehicles. But for how long? The world is changing, and it's an adapt or die kind of situation out there. With people getting more and more environment conscious, the rise of EVs is all but inevitable. Toyota knows this all too well. The company's relatively modest foray into the electric vehicle market speaks to its long-standing commitment to consumer choice. The company has maintained that it is crucial to offer a broad range of options, catering to varying regional demands, infrastructure capabilities, and consumer preferences. Toyota remains a strong proponent of hybrid and hydrogen fuel cell technologies, arguing that these solutions can help transition towards sustainability in a more gradual, inclusive way. In public remarks, Toyota chairman Akio Toyoda has made it clear that while the company is not opposed to EVs, it recognizes that a blanket shift to electric mobility could pose challenges, particularly in regions with limited charging infrastructure or where consumers may have concerns about the costs and range limitations of EVs. Toyota is investing heavily in next-generation engine technology, aiming to strike a balance between maintaining its existing product lineup while developing cleaner alternatives. These innovations are crucial as the company seeks to address both the regulatory pressures surrounding emissions and the evolving preferences of eco-conscious consumers. Toyota has remained steadfast in its belief that there is no one-size-fits-all approach to the future of mobility. For instance, the company is exploring hydrogen combustion engines alongside hybrid systems and fully electric drivetrains as part of its commitment to diversifying the types of powertrains available to consumers. Akio Toyoda, the chairman of Toyota, has maintained that while electric vehicles are part of the solution, they are not the universal answer, especially in regions where charging infrastructure remains underdeveloped. He pointed out that the transition to electric vehicles could be slower than expected due to the need for vast investments in charging networks, battery production, and grid capacity, particularly in developing countries and remote areas. Moreover, Toyota's leadership maintains that hydrogen power holds significant potential in addressing the needs of diverse global markets. Hydrogen fuel, unlike electricity, can be produced from a variety of sources, including renewable energy, and has the potential to power vehicles without the need for heavy reliance on the electricity grid. This is especially important for regions where electricity generation and distribution systems are not robust or widespread. So what are these hydrogen engines all about? Well, let's find out. Toyota's new hydrogen-powered engine. Toyota's groundbreaking new hydrogen-powered combustion engine marks a significant leap in the evolution of alternative energy technologies within the automotive sector. The development of this hydrogen-powered engine is not just a technical innovation, but a strategic move to combat the environmental challenges posed by internal combustion engines and the rise of electric vehicles. Hydrogen, when burned in the engine, reacts with oxygen, creating a chemical reaction that produces power while emitting only harmless water vapor, essentially eliminating the pollutants typically associated with fossil fuel combustion. This design allows Toyota to significantly reduce the environmental footprint of its vehicles while still utilizing the combustion engine's established power dynamics. In terms of performance, this hydrogen-powered engine delivers exceptional power output while maintaining the smooth and responsive dynamics that drivers expect from traditional combustion engines. Toyota has spent years refining this technology, ensuring that it provides the same level of driving enjoyment, acceleration, and performance as gasoline engines without the environmental drawbacks. The hydrogen combustion engine is designed to be highly efficient, offering a longer range and faster refueling time compared to electric vehicles that rely on charging stations. Additionally, the engine's ability to operate on hydrogen, which can be produced from a range of renewable sources, makes it a highly sustainable alternative to fossil fuels, contributing to Toyota's vision of a diverse energy future. But this did not happen overnight. Toyota's commitment to hydrogen-powered vehicles began in 1992, marking the company's foresight into sustainable fuel alternatives at a time when the reliance on fossil fuels and the environmental consequences of climate change were becoming increasingly urgent issues. In 1996, Toyota made a significant leap by developing its first fuel cell electric vehicle, or FCEV, a prototype based on the RAV4. This milestone proved that hydrogen fuel cells could be used to power a vehicle, a concept previously considered ambitious. The prototype demonstrated not only the feasibility of hydrogen as a fuel, but also the potential for zero-emission driving to become a practical reality. Achieving this breakthrough required overcoming numerous engineering challenges, such as developing the fuel cell stack, creating hydrogen storage solutions, and integrating electric drive components into a working vehicle. The RAV4 FCEV served as a vital proof of concept, validating that hydrogen could offer an eco-friendly alternative to conventional gasoline and diesel engines without compromising performance. Throughout the late 1990s and early 2000s, Toyota's commitment to hydrogen technology deepened as it continued to invest in research and development. The company worked closely with research institutions and government bodies to accelerate the commercialization of hydrogen fuel cells. This included testing hydrogen-powered vehicles in diverse environments and exploring applications not only for passenger cars, but also for larger commercial vehicles, such as buses and trucks. In 2002, Toyota introduced the Toyota FCHV, or Fuel Cell Hybrid Vehicle, which combined both hydrogen fuel cell and hybrid technology. By the 2010s, Toyota had made substantial progress with its hydrogen vehicle lineup. The company participated in numerous pilot programs and demonstrations, collaborating with local governments, businesses, and stakeholders to build a robust hydrogen infrastructure necessary for widespread adoption. These years of research and development gave us the Mirai. Toyota Mirai, the future. Mirai translates to future in Japanese. This Toyota line represents a groundbreaking achievement in the automotive world as the first mid-size hydrogen fuel cell vehicle, or FCV, to be mass-produced and sold commercially. Unveiled at the 2014 Los Angeles Auto Show, the Mirai marked a significant milestone in Toyota's long-standing commitment to sustainable mobility and clean energy technology. The Mirai's design and development owe much to its predecessors, including the Toyota FCV-R and the FCV concept cars. The FCV-R, first revealed at the 2011 Tokyo Motor Show, was Toyota's initial foray into serious hydrogen technology, while the 2013 FCV concept took things a step further. This striking, bright blue sedan was designed to resemble a water droplet, an artistic expression of the vehicle's zero-emissions nature, as its only byproduct is water vapor. The concept car featured a large front grille and openings to optimize airflow, which was essential for cooling the fuel cell and allowing oxygen intake for the hydrogen process. Its dimensions were similar to that of the Toyota Camry, making it a familiar and comfortable choice for consumers while showcasing advanced fuel cell technology. At the heart of the FCV concept was a state-of-the-art fuel cell system that doubled the output of its predecessor, the Toyota FCHV ADV. This innovation delivered more than 100 kilowatts of power while significantly reducing the size of the fuel cell unit, offering both power and efficiency in a more compact form. Additionally, the FCV concept incorporated 2 high-pressure hydrogen tanks placed strategically under the vehicle, optimizing space and enhancing performance. One of the Mirai's unique features was the seamless integration of Toyota's hybrid synergy drive technology. This allowed the FCV to operate efficiently under various driving conditions. For example, in urban environments with low speeds, the Mirai functioned similarly to a traditional electric vehicle, drawing energy from a battery that could be replenished through regenerative braking. When higher speeds were needed, the hydrogen fuel cell took over, powering the vehicle's electric motor. By June 2014, Toyota was nearing the final stages of development, preparing for the Mirai's official launch in December 2014, focusing initially on regions with established hydrogen refueling infrastructure. The production model, known as the first-generation Toyota Mirai, was a significant step forward in the automotive industry. Combining fuel cell and hybrid technology, the Mirai introduced a single-speed transmission and a compact nickel-metal hydride battery. Its performance was as remarkable as its environmental benefits. In the US, the EPA cycle showed that the Mirai could travel 312 miles or 502 kilometers on a full tank of hydrogen, offering a practical range for everyday use. All of this without emitting any harmful pollutants. The Toyota Fuel Cell System, or TFCS, a sophisticated integration of fuel cell and hybrid technology, formed the core of the Mirai. This system incorporated key components such as the fuel cell stack, a boost converter, and high-pressure hydrogen tanks. It enabled the vehicle to accelerate from 0 to 60 miles per hour in just 9 seconds. On top of that, refueling the Mirai was also incredibly quick, taking only 3 to 5 minutes thanks to the advanced hydrogen storage and fueling system. Safety was a top priority in the Mirai's design. Toyota implemented extensive crash testing to ensure the vehicle could protect occupants and key components in the event of a collision. The structure was reinforced with carbon fiber reinforced polymers, which helped absorb impact energy. Additionally, hydrogen sensors were strategically placed throughout the vehicle to detect any potential leaks and automatically shut off the tank's main stop valves. The layout of the hydrogen tanks was also designed to enhance safety, positioning them outside the passenger cabin and ensuring that any leaking hydrogen would dissipate quickly into the atmosphere. This careful attention to safety ensured that the Mirai met and exceeded rigorous industry standards. The success of the Mirai also demonstrated the potential of hydrogen as a clean, efficient alternative to traditional gasoline and diesel vehicles, encouraging further investment in hydrogen infrastructure and technology. Building on the success of the first-generation Mirai, Toyota introduced its second-generation model under the JPD20 code in October 2019, with production officially beginning in December 2020. This new iteration of the Mirai, based on Toyota's new global architecture platform, boasts several changes, most notably in the vehicle's rear motor, rear-wheel drive layout, which enhances its driving dynamics and offers a more engaging experience for enthusiasts. This new platform not only improves weight distribution for better handling, but also frees up more interior space. Powering the second-generation Mirai is an upgraded fuel cell powertrain that delivers 182 horsepower and 300 Newton-meters of torque. The Mirai's electric motor is paired with a single-speed transmission and is supported by a compact lithium-ion battery, ensuring optimal energy efficiency. The vehicle also features 3 hydrogen tanks, providing a combined storage capacity of 141 liters, which extends the vehicle's range to an impressive 647 kilometers or 402 miles on a single tank. In terms of design, the second-generation Mirai boasts a sleek modern aesthetic that prioritizes aerodynamics, with smooth curves and sharp lines that reduce drag and enhance efficiency. The interior reflects a premium feel, featuring high-quality materials and a suite of advanced technology designed to improve driving experience. The infotainment system, updated in March 2023, provides enhanced connectivity and an intuitive user interface, making it easier for drivers to stay connected while on the road. In addition, the Mirai comes equipped with Toyota's Teammate Level 2 driver assistance system, which includes groundbreaking features such as hands-off driving on designated roads and an intelligent parking assistance system. Safety continues to be a cornerstone of the Mirai's design, and the vehicle received a prestigious 5-star safety rating from Euro NCAP in September 2021. Since its launch, the second-generation Mirai has seen steady success in global markets, with a total of 21,475 units sold by November 2022. The United States emerged as the largest market, with 11,368 units sold, followed by Japan at 7,435 units, and other regions contributing 2,622 units. While these figures may seem modest compared to traditional vehicles, they reflect the early stages of hydrogen vehicle adoption. Naturally, Toyota fully plans to expand its hydrogen vehicle lineup. In fact, there's already another player in town, the Toyota Crown. Built around a 4-door layout, the Toyota Crown sedan features a longitudinal front-engine configuration paired with a rear-wheel drive setup. The Crown sedan offers 2 distinct powertrain configurations, a hybrid and a fuel cell electric vehicle, or FCEV variant. The Crown FCEV is particularly remarkable, incorporating the advanced fuel cell technology pioneered in the second-generation Mirai. It is equipped with 3 high-pressure hydrogen tanks that give the vehicle an impressive driving range of approximately 820 kilometers on a single tank, a distance that exceeds many traditional fuel-powered vehicles. Refueling is a swift process, taking just around 3 minutes. The hydrogen fuel cell system works in tandem with a lithium-ion battery to support the vehicle's electric motor. This seamless integration provides both an eco-friendly driving experience and exceptional performance. Inside, the Crown sedan is a sanctuary of luxury and technology. The cabin is crafted with premium materials, featuring elegant finishes and an ergonomic layout that creates a comfortable and refined atmosphere for both drivers and passengers. Toyota has equipped the vehicle with an intuitive infotainment system that includes high-quality audio options, premium connectivity features, and user-friendly controls. The Toyota Crown sedan made its debut in July 2022 with a pre-production showcase, and after much anticipation, it officially launched in Japan on November 2, 2023. It went on sale shortly thereafter on November 13th, with Toyota setting an ambitious monthly sales target of 600 units. This marks a significant step in the brand's ongoing expansion of its premium offerings. While the Crown sedan's initial launch focused on the Japanese market, Toyota has global aspirations for the model. In November 2022, the company revealed plans to introduce the Crown sedan to the Chinese market through a collaboration with FAO Toyota. A mock-up prototype of the vehicle was first displayed at the Guangzhou Auto Show in December 2022, followed by the unveiling of a working prototype of the FCEV variant at the 2023 Fuji 24 Hours Endurance Race. The Crown sedan will be available in 2 distinct grades in China, Premium and Extreme. These options are tailored to meet the expectations of luxury car buyers in the competitive Chinese market, offering a range of features that cater to both performance-focused and luxury-oriented consumers. With its blend of innovative technology, luxurious comfort, and performance-driven design, the Crown sedan represents a bold new chapter for Toyota in the premium automotive segment. Now let's take a look at the technical aspects of these vehicles and their engines. How the hydrogen-powered combustion engine works. Hydrogen fuel is chemically similar to natural gas and can be combusted similarly. However, hydrogen combustion differs significantly from burning gasoline, as it offers the potential for nearly 0 carbon dioxide emissions during operation. Unlike gasoline engines that emit harmful pollutants such as carbon monoxide and hydrocarbons, the only byproduct of hydrogen combustion is water vapor. The key difference between hydrogen combustion engines and traditional gasoline engines lies in how the fuel is introduced and burned. In a conventional gasoline engine, fuel is mixed with air and ignited by spark plugs. Hydrogen combustion, on the other hand, involves burning hydrogen directly with air in the combustion chamber, without the need for complex chemical reactions such as those in a fuel cell system. Hydrogen burns at a much faster rate than gasoline, which can lead to more efficient energy release within the engine. This characteristic not only results in higher combustion speeds, but also increases the thermal efficiency of the engine. Another distinguishing feature of Toyota's hydrogen combustion engine is its minimal use of engine oil. Traditional gasoline engines rely on oil for lubrication, as the combustion process can produce significant heat and wear. With hydrogen, the combustion process is cleaner and generates much less particulate matter, which reduces the need for oil changes and minimizes engine degradation over time. This not only makes the engine more efficient, but also reduces the long-term maintenance costs associated with conventional combustion engines. The hydrogen combustion engine also produces minimal carbon buildup, another issue that has long plagued traditional gasoline engines. When hydrogen is ignited, it burns at a rapid pace, enabling faster energy release and quicker acceleration. This can provide a performance boost, making the hydrogen-powered engine feel responsive and agile, similar to what drivers experience in traditional high-performance gasoline engines. The increased combustion speed can also improve the overall efficiency of the engine, as the fuel is converted to power more quickly, reducing the wasted energy that can occur in slower combustion processes. Hydrogen combustion engines offer a promising compromise between the environmental benefits of electric vehicles and the traditional performance and refueling convenience of combustion engines. By utilizing hydrogen as a fuel source, Toyota aims to provide a greener alternative without compromising on driving dynamics, performance, or the infrastructure challenges associated with fully electric vehicles. Toyota's commitment to advancing hydrogen technology has taken a significant step forward with the performance-focused modifications made to its hydrogen-powered combustion engine. One of the key areas of development involves enhancing existing engine platforms, such as the 1.6-liter turbocharged engine used in performance models like the GR Yaris and GR Corolla. These engines, known for their responsiveness and agility, have been modified to burn hydrogen, allowing Toyota to retain the high-performance characteristics of these motors, while embracing a cleaner, more sustainable fuel source. The primary modification involves adapting the engine's fuel system and combustion chamber to accommodate hydrogen as a direct fuel. Toyota's engineers have ensured that engines maintain the performance levels expected of high-performance vehicles while keeping emissions near zero. Toyota has subjected its hydrogen-powered engines to rigorous testing to evaluate their performance under extreme conditions. A notable example is the performance of the Toyota Corolla Sport race car, which has been equipped with a hydrogen-powered combustion engine for track testing. These tests focus on key parameters such as handling, power delivery, fuel efficiency, and overall engine durability, ensuring that the engine performs reliably in both competitive racing environments and everyday driving scenarios. Motorsport applications, where performance demands are high, offer an ideal proving ground for testing the limits of hydrogen combustion technology and gathering valuable data. But it's not just engines. Toyota's vision is far broader than this. Toyota's approach beyond automotive engineering. While Toyota is making significant strides in the development of hydrogen-powered vehicles, it is equally committed to expanding the infrastructure necessary to support the widespread adoption of hydrogen technology. This includes a strategic push into hydrogen fueling stations, which are essential for providing an accessible and reliable fueling network for hydrogen-powered vehicles. After all, for hydrogen cars to become a practical alternative to gasoline or electric vehicles, an extensive refueling infrastructure must be in place. The company is working in collaboration with governments, energy providers, and other stakeholders to build and expand hydrogen refueling networks, particularly in regions where hydrogen adoption is poised to grow, ensuring that drivers can conveniently access clean energy wherever they go. Beyond the infrastructure, Toyota's commitment to hydrogen is also rooted in the development of the necessary technologies for energy production. One of the most promising methods for producing hydrogen fuel is through the electrolysis of water. In this process, water is split into hydrogen and oxygen using electricity. When renewable energy sources like solar or wind power are used to drive electrolysis, the hydrogen produced becomes a truly green fuel, free from the carbon emissions associated with traditional fossil fuels. This approach not only positions hydrogen as a key player in Toyota's vision for zero-emissions transportation, but also aligns with the company's broader goal of reducing its carbon footprint and contributing to the global transition to renewable energy sources. However, it's not all that simple. While hydrogen offers a clean and sustainable alternative to traditional fossil fuels, significant obstacles remain in fully realizing its potential, particularly regarding water splitting, hydrogen storage, and engine adaptation. For example, although electrolysis has been around for decades, it remains an energy-intensive process, requiring a substantial amount of electricity to break water molecules into hydrogen and oxygen. The efficiency of this process is crucial because the amount of electricity used directly impacts the overall environmental benefits of hydrogen production. To address this, Toyota is investing heavily in developing more efficient electrolysis methods that consume less energy and reduce the carbon footprint of hydrogen production. Moreover, ensuring that hydrogen is produced from renewable energy sources like solar or wind power is essential for the hydrogen economy to be truly sustainable. Toyota's commitment to improving the electrolysis process through advanced technology and renewable energy integration is central to making hydrogen mainstream. Storage is another significant hurdle in the widespread adoption of hydrogen-powered vehicles. Hydrogen is a low-density gas, which means it requires high-pressure tanks or cryogenic storage systems to store enough fuel for a practical driving range. These storage systems must be both lightweight and durable to ensure they are safe and efficient for everyday use. Toyota is actively working on improving the storage capabilities of hydrogen, developing advanced materials that allow for higher density hydrogen storage at lower pressures. This would not only enhance the safety of hydrogen tanks, but also make them more cost-effective. The adaptation of hydrogen combustion engines to existing vehicle platforms also presents a unique set of challenges. Hydrogen combustion engines, while similar in function to traditional gasoline engines, require modifications to handle the properties of hydrogen fuel, such as its fast combustion rate and the potential for higher temperatures within the combustion chamber. In addition, the engines must be engineered to minimize hydrogen's propensity to backfire or cause engine knock. Toyota has been at the forefront of this adaptation process, making incremental yet significant advancements in fine-tuning hydrogen combustion engines for optimized performance. This includes adjustments to engine timing, injection systems, and fuel-air mixture processes, all of which are crucial to ensuring smooth and efficient engine operation while maintaining the environmental benefits of hydrogen combustion. Despite these technological hurdles, Toyota's dedication to overcoming these challenges positions the company as a leader in hydrogen innovation. The company's research and development efforts are focused on breaking down the barriers of hydrogen technology, enabling faster and more efficient hydrogen production, improving fuel storage and delivery, and refining the performance of hydrogen engines. The impact of Toyota's work on the automotive industry could be transformative. By advancing hydrogen engine technology and addressing the infrastructure challenges associated with hydrogen fueling, Toyota has the potential to revolutionize the way cars are powered, offering a cleaner, more sustainable alternative to both gasoline and electric vehicles. They could even run EV manufacturers out of business. Think of it like this: what would one rather do? Make some adjustments to the car they own and convert it to a hydrogen vehicle, or spend an exorbitant sum to buy a new EV? Plus, what will become of all the defunct internal combustion cars? Then there's the familiarity factor as well. Hydrogen cars, if successfully introduced, will surely give people like Elon Musk a serious headache. And it's a change for the better. The widespread adoption of hydrogen-powered vehicles could drastically reduce greenhouse gas emissions from the transportation sector, which is one of the largest contributors to climate change. Unlike traditional combustion engines that emit harmful pollutants like carbon dioxide, nitrogen oxides, and particulate matter, hydrogen combustion engines produce only water vapor, making them an essential tool in the fight against air pollution and climate change. Furthermore, hydrogen fuel cells and combustion engines offer the added benefit of faster refueling times compared to electric vehicles, addressing one of the key drawbacks of electric mobility. This makes hydrogen-powered vehicles a more practical option for long-distance travel and regular commuting. The challenges of electric cars and hydrogen solutions. Electric vehicles have become one of the leading solutions in the drive for sustainable transportation, but they come with their own set of challenges that continue to limit their widespread adoption. The primary concern surrounding EVs is the issue of charging times. Despite advancements in charging technology, recharging an electric vehicle still takes significantly longer than refueling a gasoline or diesel-powered vehicle. Even with fast chargers, the time required to recharge a battery can range from 30 minutes to several hours, depending on the power source and battery size. This slow process poses a challenge for long-distance travel and for users who have limited access to fast charging stations. The lack of a robust charging infrastructure in many regions further exacerbates this issue. But that's not all. EV batteries, typically made from lithium-ion or other rare minerals, require a complex and resource-intensive manufacturing process. This raises concerns over the environmental impact of mining these materials, which often takes place in regions with limited environmental oversight and labor rights protections. The growing demand for EVs has led to an increased need for these resources, putting pressure on global supply chains and raising concerns about the sustainability of battery production. Furthermore, when EV batteries reach the end of their life cycle, recycling and disposal become significant challenges. Though there are ongoing efforts to improve battery recycling technologies, the process remains costly and inefficient, leading to concerns over waste and potential environmental hazards. Hydrogen-powered vehicles, on the other hand, do not rely on the complexities and limitations of battery storage. Instead, they harness the power of hydrogen fuel cells, which generate electricity through a chemical reaction between hydrogen and oxygen, emitting only water vapor as a byproduct. This process significantly reduces the need for large, heavy batteries and offers a solution to the limitations posed by current EV charging infrastructure. Hydrogen refueling stations can be set up similarly to traditional fuel stations, providing a much faster refueling time of just a few minutes, which is comparable to gasoline and diesel-powered vehicles. This makes hydrogen cars particularly attractive in areas where quick refueling is essential for convenience, such as long-haul trucking, commercial vehicles, and industrial applications. Additionally, hydrogen is a viable fuel option for heavy-duty applications, where battery electric vehicles may face limitations due to their size, weight, and need for frequent recharging. Trucks, buses, and industrial machinery that rely on long endurance and high power output stand to benefit significantly from hydrogen fuel cells, which offer better efficiency under load and shorter refueling times compared to their electric counterparts. Overall, Toyota's focus on hydrogen vehicles is part of a broader strategy to diversify the types of vehicles and solutions available to meet the needs of different markets. By offering a range of vehicles designed to accommodate different regional needs, Toyota is helping to ensure that the transition to a more sustainable future is inclusive, adaptable, and accessible across the globe. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.